Good morning friends. Today I am going to explain one of the important topic of electromagnetic induction. Here, obtain an expression for the magnetic energy stored in a solenoid in terms of magnetic field area length of the solenoid. Here, just a note for understanding what is solenoid. Solenoid means a coil of wire wound over a cylindrical frame uniformly. Its diameter is small as compared to its length. Here just you imagine a solenoid means a coil in which number of turns are there and a current is flowing in the solenoid, and due to which an induced EMF is set up in developed in the particular coil. Now when during the passage of AC current through the solenoid or coil, some work has to be done against the back EMF. So already back EMF is set up in the coil. So whenever AC current is passes through this one, some work is done by the current, AC current, against this back EMF. So first of all we are going to calculate the what is the work done by the current against the back EMF, and how that work done is stored in a magnetic field. So that we have to calculate. So for that purpose, first of all we have to calculate the smaller work done. So that is small work done can be written as dW V dq. So this is the for small work done. So potential and charge, small charge dq. So now we are introducing V in terms of electromotive force. This is the potential and this is the E is nothing but a electromotive force. This can be written as amount of work done to move charge dq against this back EMF. So against this back EMF is can be given as dW is equal to minus against, so that's why minus we have to introduce minus E into dq. Now we know that according to the Faraday's second law, E is equal to minus of d phi b by dt. Here and I is equal to the rate of change of charges, that is dq by dt, or we can write dq is equal to I dt. So dw is can be written as minus, and this is also minus, so that's why we can write plus d phi b by dt into dq value is I dt or dt I we can write. Next here phi b is nothing but a magnetic flux. So magnetic flux is equal to product of self inductance into current, that is Li. So we have to substitute the value of phi b in this equation, then we will get d by dt of Li into dt I. So that can be written as dt that get cancelled, then Li di we can write this equation. Now this is the small work done, okay, that is done the work done by the AC current against the back EMF. Now the total work done in establishing the maximum current from 0 to I naught is given by. So for the total work done, just we have to integrate this equation, dW equation. Then we will get integrating to that equation, dW will be W is equal to 0 to I naught Li into di. Here W is equal to L is taken out, mu 0 to I naught I into di. Then W is equal to L, and this integration of this one can be written as I square by 2, 0 to I naught is the limits. When you substitute the limits, then W or total work done in establishing the maximum current in the circuit or in the coil, particular coil or solenoid, can be written as L I naught square by 2. So let us take this is equation number 1. So here this work done is stored in the form of potential energy in the magnetic field U. So magnetic field is represented by a letter U, and here this total work done is stored in the magnetic field in the form of potential energy. So that's why we can directly these two equations are equating, or simply W is equal to the U, and that can be written as 1 by 2, this same as it is 1 by 2 L I naught square, that is 1 by 2 L I naught square. Let us take this is equation number 2. So this work done is nothing but a potential energy. Now in case of a solenoid, we know that Magnetic induction is equal to the mu naught and I naught. Mu naught is the permeability constant, N is the number of turns in the solenoid, I naught is the maximum current in the solenoid. So we can write by this equation I naught is equal to B by mu naught N. Okay, and at the same time we know that in solenoid self inductance is equal to the mu naught N square AL, where A is the area of cross section, L is the length of the solenoid, mu naught is the permeability constant, and N is the number of turns in the solenoid. Now we are going to substitute the value of L and I naught in equation number 2. So this is the equation number 2, that is U is equal to 1 by 2 L I naught square. Then we will get U is equal to 1 by 2 mu naught N square AL into B by mu naught N square. So N square get cancelled. Then we will get U is equal to B square AL by 2 mu naught. So this is equation number 3. So this is the expression for the magnetic energy stored in the solenoid and in terms of magnetic field. Thank you. For more videos, subscribe my channel Physics.